Hello everyone, welcome back to the channel. In my previous video, I explained the BFS Breadth First Search program line by line, including the input, output, queue operation, variable changes and execution flow to make it easy for beginners to understand. In today's video, we will learn depth first search implementation in Python. Before we start the DFS program, let's first understand the difference between the DFS and BFS. This comparison will make the DFS code much easier to understand. Most of the code, such as taking graph input, creating the graph dictionary and maintaining the visited list, is exactly same as BFS. The main difference is that DFS uses recursion instead of queue. In BFS program, we used queue to store nodes and visited them level by level. In the DFS program, there is no queue. Instead, the function calls itself using the DFS function. In the DFS function, 3 parameters: visited, graph, neighbor. This recursive call helps DFS go as deep as possible into the one branch before returning to explore the next branch. This process is called backtracking. So, while learning this program, you only need to focus on two new concepts: recursive and backtracking. First one is recursion. Recursion means a function calls itself. In the DFS program, this line performs the recursion. DFS parameters are visited, graph, neighbor. Let's see it with an example. See the graph. A is the parent node, it has the children BC, and B has the parent node, D are neighboring node, C as the child, F. Starting node is A. Output starts with A. DFS checks the neighbors of the A. The first neighbor is B. So the function calls itself. DFS A calls DFS B. Now the output becomes A, B. Again, B has the neighbor D. So the function calls itself again. Now the output A, B, D. This is called recursion, because the same function keeps calling itself to visit deeper nodes. Second, backtracking. Now node D has no neighbors, so the function finishes for D and returns the previous function call, that is B. This returning is called backtracking. A visited B, D. After that, it go back to the B. After returning to B, DFS checks whether B has another unvisited neighbor. Yes, it finds E. Output becomes A, B, D, E. E has neighbors F. Output A, B, D, E, F. F has no neighbors, so DFS backtracks again. F, E, B, A means A to B, B to E, E to F. That is the backtracking. Now DFS returns to A and checks the next neighbor C. Now our output is A, B, D, E, F, C. C has the neighbors F, but F is already visited, so DFS skips it. Final output is DFS traversal is A, B, D, E, F, C. Remember the point's recursion. The function calls itself to go deeper. Backtracking is for when there are no more visited neighbors. The function returns to the previous node and continues from there. This is the concept of the DFS. Let's check our output for the DFS algorithm for graph. Run the program. Our parent node is A and neighbors are B and C. Then second parent is B. Children D and E. After A, B, C, next node is C. C not have this children, just press the enter. After fourth node D, no need to enter none. A, B, C, D, E. E has the neighbor F. F, last node, just press the enter. A, B, C, D, E, F, all node we finished. Then press the quit. Then starting node you have to enter A. We will get the output A, B, D, E, F, C, DFS traversal. Thank you.